So we need 6 equations. So what equations are we going to use?
Sum of forces,
Yeah, in?
x, y, and z.
Right, so sum of the forces in the x is one equation, sum of the forces in the y is another one, sum of the forces in the z, what else?
Sum of moments.
Some of the moments in the
X, Y, Z.
x, y, and z. Those are the 6 equations that we're going to use. So now Jason. Oh, Claire?
I actually have a question because it's a 3-body
3D.
or a 3D picture, but we only need one free body. We only need one free body because we have the moments now, so we can have
That's
6
correct.
moments. Okay.
That's right. Because we now know about moments, we have added we've added a sum of the forces in the z. On a 2D body, Jason, on a 2D body, how many equations do we have? 3. What are they?
Sum of the forces in the x, sum of the forces in the y, and sum of the z.
Right. So what equations, Jose, did we add by going from 2D to 3D?
Sum of the forces in the z,
Correct?
and the sum of the moments in the x and y.
That's right. Okay. If we go back to our problem with the plate, this was a 3D problem. But Sam, what equations could I use? What were the only equations I could use? Normally on a 3D problem we have 6 equations, but which ones worked?
Some of the moments in the x.
Some of the moments in the x,
Force in the z.
force in the z,
And some of the forces in, I meant, moments in the x.
moments, I'm sorry, so moments in the x.
Moments in the y.
Moments in the y, right. So why can we not use some of the forces in the x? There are no forces in the x. How come I can't do some of the forces in the y? There are no forces in the y. How come I can't do some of the moments in the z? Because all the forces are going in the z, so they can't create a moment about the z. So there's the potential in a 3D problem to have 6 equations, but there are times where you can't get all 6, right? And in this particular case, we only needed 3 equations because we had 3 unknowns. But in this guy, we have 6 unknowns, and we need 6 equations. So now, let's figure out what equations we want to use. So Esau, Lonnie? No. Esau, which equation would you like to do first? So it's going to take some time. Look at all the possible equations. Or actually, Isaac, what 6 equations are we going to use?
Well, I see that we have some given
Let's do
forces
one at a
in
time.
the
Pick
z.
one equation.
One equation.
Yeah.
I would go sum of forces in the z.
Okay. So sum of the forces in the z will give us, you pick the best equation. Why am I saying that's the best equation to pick first?
There's only one unknown.
There's only one unknown in it. We know what CZ is, right? What is it? 200.
Yeah.
Because when we sum the forces in the z, it's CZ minus 200 equals 0. So that's the best equation to do first. Daniel, if we did sum of the forces in the x, how many unknowns would we have?
Yeah. 3.
Sounds like a yucky equation, huh? Okay. Eugene, how about if we did sum of the forces in the y? How many unknowns do we have?
Y,
2. 2 forces unknown. Again, not such a great, I don't think you got to say that, did you?
Yeah, I did.
Oh, you did, okay. We have 2 unknowns in that equation. That's not such a great equation either. Okay, Maria, how about some of the moments about the x? Rather than ask, let's do it. Does AX create a moment about X? No, because it's parallel. Does BX create a moment about X? How about CX? CX? No, because it's parallel. How about CZ?
Yes.
Does it create a positive or negative? Positive. How about AY and BY? Positive or negative? Negative. I don't see anybody using right-hand rule. You could do it in your head.
Yeah.
Really? That's good.
Yeah.
Okay, how about the 200 Newton force? Positive or negative about X?
Negative.
Negative. How about 400? No moment. Why? Parallel. How about 300? Negative. So how's 3D right-hand rule for you guys? Are you experts or close to it? Okay, do you want to go solve this damn problem vectorially?
No.
With R cross Fs? I wouldn't even want to try it.
Nah.
How many of you want to do vectors still? Yes! Okay, how many of you do like 3D right-hand rule now?
Like it?
Okay, like it better than vectors.
Okay, yeah, there we
Who
go.
likes 3D right-hand rule better? Hi, be proud. Ah, it's awesome. You guys got converted. I mean, isn't it more physical? You know physically what's going on, where things are spinning. You do the R cross F plus R cross F plus R cross F. You just chug into your numbers. Okay. So the only equation that has one unknown is CZ, right? So we could solve for CZ. But then how many equations are we going to have left? 5. And how many unknowns do we have left? 5. So how many equations and how many unknowns do we have to solve? 5. What kind of matrix do we have? 5 by 5. Okay? So here's all the math. Okay? So why don't you take time with the person next to you and look at it? First I did the force equations. And notice what I do. Okay, you guys, you know you always have to do this, right? Sum of the forces or whatever equals 0. You have to set up the equilibrium equations. And then I move the whole number to the other side and I box it in and write number 1. So I know that's equation number 1. Number 2, number 3 would have been the one I did first. Then here are the moment equations. Okay. And then we could have done a 5 by 5 matrix and we would get the answers. So what I want you to do is make sure you agree with the person next to you that some of the forces in the Y is correct. And then check it off. And then write down, check off when you agree. So I want you to put a check mark next to every equation that you agree with. Make sure you check my work. Make sure I'm right. Did I make a mistake?
Well, there's the numbering.
Oh, sorry. It's because I did it vectorially too. And so, a long time ago, I used to hand out the solutions for vectorially and 3D right-hand roll, but I realized that you guys don't need to see that garbage. So that's why I skipped 4, 5, and 6. Okay, is the force of X equation okay?
Yeah.
How about force Y?
Yes.
How about force Z?
Yes.
Okay. How about moment X?
Yes.
How about moment Y?
I don't know.
And moment Z?
Yes.
Okay. And you can check them out on your own. It's just more practice doing 3D right-hand rule, right? Jabin?
I noticed you have you already declared that it's positive moment for each of those. Is that just a symbol determining as the moment? And
Yeah,
you weren't
I don't,
figuring
you
that out?
don't need to do this anymore because we have, so, let's see. On a free body diagram, you show me where the positive X and Y axis is, right? So that means that when I have a plus for a force, you know it's going up. Let's say for Y, it's going up because on the free body diagram, I showed the sign convention for positive. Does everybody see that? So when I put a positive X, Y, and Z axis on a free body diagram, I'm showing you the positive sign convention for forces. Okay? But typically on a free body diagram, you don't show the positive, you don't draw a moment about each axis to show what the positive sign convention is. So typically what's done is we put a positive here, showing what the positive is. But in our class, we already agreed that using the right-hand rule, going counterclockwise is positive, so we didn't need to write this. Okay, so this is just showing the sign convention. But we're not doing that because we already agreed in class that this is positive. Okay, good question. Okay, so just check the math, do it with a 5x5 matrix. Should we set that up? Let's set it up. So we have equation 1, equation 2, equation, what is it? 7, 8, 9? Okay, I have to draw little lines here. Okay, so let's put in, what's the unknowns? AX, AY, BX, BY, and CX, right? Oh, damn it, I wrote it out, sorry, I'm cursing too much today. Sorry, this shouldn't be here, right? Okay, so equation number 1 had AX plus BX plus CX is 400, right? So 400, 1, 0, 1, 0, 1, right? Because it was AX plus BX plus CX is 400. I want to make sure everybody's okay with that. So the first equation said AX plus BX plus CX equals 400. How many of you are using matrices in your calculator versus putting in the number of equations and number of unknowns? So how many of you are using matrices? Okay. And how many of you are just putting in the equations? Okay, equation 2 was AY plus BY is equal to negative 300. I feel like I'm in math 6, putting in all these ones and zeros. Okay, equations now are up above, so let's look above. Equation 7 is 0.3 times AY plus 0.5 times BY is equal to negative 250.
So we didn't have to put equation 3 in?
No, because you used equation 3 to solve CZ. You're down to only 5 equations, 5 unknowns now. Equation 8, 0.
Raise it up a little bit more.
Yeah, sorry, 0.3, yeah, times AX plus 0.5 BX is equal to 220. And 0.3 AY plus 0.3 BY minus 0.25 CX is equal to negative 270. So 5 equations, 5 unknowns. That's a negative.
What's the last one?
So it says negative 0.25, because look right here. It's 0.3 times AY, 0.3 times BY minus 0.25 times CX. So everybody understands how I'm writing it, right?
AX, AY, BX, BY.
So everybody look up here for a minute. So it's 0, so equation 9 is 0 times AX plus 0.3 times AY plus 0 times BX plus 0.3 times BY minus 0.25 times CX is equal to negative 270.
And it helps.
Oh, yeah, it helps me to put this in. I put it light, just so that I'm organized. Is that what you meant, Sarah?
No, I put the index over the first column, AY over the.
Oh, that's a great idea. AX, AY, BX, BY, CX. Great. So this is kind of all this, and this is all scrap, yeah. Carolyn?
Would you accept that on an exam or on homework, just having the matrix there?
Yeah, you can have the matrix. But I do want to see all this equations, right? I want to see all the equations, and then you have an option. Either you do it by a matrix in the calculator, or you shove all these equations into a calculator, or you do what I did, which was substitution. Okay, so once you have, this is a good question. Once you have all the equations, you could just plug all the equations into your calculator and just spit out what AX, BX, Y, and stuff are. Or you could show me the matrix and then plug it in and give me the answers, or you could do this plug inside. Lucas.
Just wondering, would the moments come out different if the origin was in a different spot?
Well, my equations here are some of the moments about the x, y, and z, right? Okay? So in this case, if you look at my free body diagram, here's my x, y, and z. So I'm telling you, whoever's reading it, what I'm finding my moments about. If I did, let's go to the original problem, if instead I decided to put my origin up here, my moments would be different. Does everybody agree with that? If I move my origin here, and this is x, and this is z, and this is y, would I have a different moment for x? Yeah. Would I have a different moment for y? Yes. Would I have a different moment for z? Yes, because it's off-centered. You would have different moment equations for all of these, but in the end, you would get the same answers. Okay? Your equations would be different, but the answers would be the same because the forces are still in the same spot. Everybody heard that, right? So you could put your axes wherever you want and then you solve for the moments, but in the end you're going to get the same answers as I did with keeping my origin where it was.